Okay, and welcome back, students taking Math for Business and Finance and Math Applications. And we're doing the Chapter 13 Summary Practice Test. And we had stopped at question 3, so we're on question 4. In 9 years, Rollo Company will have to repay a $100,000 loan. Assume a 6% interest rate compounded quarterly. How much must Rollo Company pay each period to have $100,000 at the end of 9 years? Okay. All right, so if it's at 9 years and it's quarterly, that's 36 periods. And the interest rate is 6% divided by the compounding of quarterly. So we end up with 1.5% interest. Okay, so let's see here. How much must Rollo pay each period to have 100,000 at the end of 9 years? So basically this is a sinking fund, okay? And so I know on the sinking fund table, we're in the textbook, as you can see, it starts at 2% on the table. So you have to look up the factor in the Business Math Handbook. And if you look in the Business Math Handbook for 36 periods at 1.5%, you'll find that the factor is 0.0212. And so you multiply that by the 100,000 and you get 212, 1, 2, 3, 4. So you end up needing $2,120 each period, having to pay each period in order to be able to have the $100,000 at the end of 9 years. Okay. Okay, number 5. Lance Industries borrowed $130,000. The company plans to set up a sinking fund that will repay the loan at the end of 18 years. Assume a 6% interest rate compounded semi-annually. Right? What amount must Lance Industry pay into the fund each period? Check your answer by table 13-1. Okay, so let's see here. 18 years. Compounded semi-annually is 36 periods, and 6% divided by 2 is 3%. So if I jump up to the sinking fund table and I look at the 3% for 36 periods, I have 0.0158 is the factor. So 0.0158 times 130,000, and that gives me an amount of $2,054. Okay, is how much needs to be put into the fund each period. I mean, semi-annually over the course of the 18 years in order to have $130,000. Okay. Now it says by checking with table 13.1. Right, so we have 3% here. We don't have 36 periods, so we have to use the Business Math Handbook. And when we do, we find that the factor ends up being 63.2759, and we're multiplying that by the 2,054. Okay, and that amount comes out to $129,968.69, and that's off due to rounding. Okay, now let's look at the amount of the rounding. I mean, $129,968.69 versus $130,000. Okay, so that's off by like 32 bucks. Okay. And that might seem like it's a lot, but it's acceptable because of the size of the numbers. We're talking about $130,000. So being off $32 due to rounding, all right, and is acceptable in this case. We're not talking about just being off by cents, okay? We're talking about being off by dollars. But 32, if you take think of it this way, 32 divided by 130,000 is only 0.0002. So we're talking about 2 10,000ths, right? 10, 100,000, 10,000ths, 2 10,000ths of a percent. Okay, so that's well within acceptable parameters of cents adjustment. But now if you ended up with let's say 120, let's say you ended up with something like 129,000, say 875. Now we're going to start pushing the realm of you're actually being wrong because you're off by $1,000 almost. Okay, so just be aware of that as far as rounding is concerned. Okay. All right, problem number 6. Joe Jan wants to receive $22,000 each year for the next 22 years. Assume a 6% interest rate compounded annually. How much must invest today? So we're looking at the present value. That's 22 years at 6%. I know that there's no 22 years on that present value table. Okay, see on the present value there's no, goes from 20 to 25. So look it up in the Business Math Handbook. And when you do, you find that the factor ends up being 12.0416, and we multiply it by 22,000, and that gives us $264,915.20. Okay, that's how much needs to be invested today in order to receive $22,000 each year for the next 22 years. All right, question number 7. Twice a year for 15 years. Twice a year for 15 years. So that's like 30 periods, right? Warren Ford invested $1,700. Okay, so that's compounded semi-annually at 6%, which divided by 2 is 3%. And what is the value of this annuity due? Okay, so remember, with the annuity due, what we have to do is we have to take the number of periods and add 1. Okay, then we find the factor. Okay, and then we multiply the factor times the 1,700, and whatever we get, we subtract 1 payment. Okay, that's how you work with the annuity due. So the number of periods is 30 plus 1, so we're looking at 31 periods when we're looking at the annuity for the annuity due, right? And we're looking at 3%. So let's jump up to the table, and of course we don't have 31 periods on that table, so you have to go to your Business Math Handbook and look that factor up. 31 periods at 3%, and that factor comes to 50.0027, and we multiply that by the 1,700, and that gives us 85,004.59. So that's step 1 here was finding the number of periods. Step 2 is multiplying by, number 1 is over here. Step number 2 is multiplying by that factor, okay? And then step number 3, we have to subtract out one of the payments. So now we subtract out $1,700, okay? And we end up with $83,304.59 is the value of the annuity due. If twice a year for 15 years, compounding semi-annually, we pay $1,700 at 6% interest. Okay. All right, so I'm going to stop here and pick up with problem number 8 in the next video. And again, if you don't understand this, pause and rewind, and watch them again. And if you still don't understand something, feel free to call and speak with an instructor or contact us via email.